So solving systems of linear equations by elimination method. Some books were called by addition. The older name used to be actually called elimination by addition. And I kind of like that name better, because it tells you two things. You're going to be adding, notice adding the equations, and you're going to be eliminating one of the variables. That's where the name came from. Elimination by addition. Bless you. Let's take an example. Let's say we have these two equations, x plus y equals to 4, and x minus y equals to 2. And I want to solve them. Again, let's go back to the name of this method, elimination by addition. Let's add the two equations. What is x plus x? Try again. 2x. Because there's a 1 here and a 1 here. What is plus y minus y?
Just cancels out.
Cancels. So you eliminated the y by adding them. So when you add them, you want to eliminate one of the variables. And what is 4 plus 2? 6. Can we solve for x now? To solve for x, what do? Divide by 2. Very good. X equals 3. Now, once you have x or y, once you have one of them, doesn't really matter which one, you go to either equation. Doesn't matter which one. Again, top or bottom. I'll take the top, no reason. And let me replace x with 3 so I can solve for y. Let x be 3. 3 plus y equals 4. Take the 3 there, y equals what? 4 minus 3, which is 1. So x is 3, y is 1. That's the solution to that problem. Again, is this really a solution? How do we test it? Plug it in. If you have a yes and a yes, the answer is yes. So in the first equation, when x is 3, we'll have 3 plus 1. Does that equal to 4? Yes. Let's take equation number 2. X is 3, y is 1. Is 3 minus 1, does that equal to 2? Yes. When you have a yes and a yes, the answer is yes. So this is a solution. Let me try another one. Three x plus 2y equals 14. 5x plus 2y equals negative 8. Again, remember the method, elimination by addition. So let me add them. What's 3 and 5? 8x. What's 2 and 2y? We got a problem. 14 minus 8, which is what? 6. Why do we have a problem?
You eliminate y.
Yep. We're supposed to eliminate one of the variables when you add them. Did we eliminate any of them? No. So we have a little problem here. Before we can go forward, we have to fix that problem. Like we have a flat tire now. Gonna fix it? Then we should be able to continue the trip. Well, how do we fix it? Well, let's think about the y's here. This plus 2y, that's plus 2y. What will happen if one of these 2y was a minus 2y? They'll cancel out. Right? So how can I change one of them to minus?
You can
Go ahead.
multiply
Multiply by what?
negative number.
Okay, multiply by negative number. What's that number? What do you think?
1.
Yep, negative 1. So let's multiply every one of these by negative 1. What's negative 1 times 3x? Negative 3x. What's negative 1 times 2y? Negative 2y. What's negative 1 times 14? Negative 14. You got to multiply every one of them, including what's after the equal sign. This, leave it alone. I could have multiplied the bottom one instead of the top one. It won't make a difference. And now let's add them and see if we can eliminate one of the variables. And when you add them, what happens to negative 2y and plus 2y? Gone. So we did eliminate y. What's minus 3x plus 5x? Plus 2x. I don't have to write the plus, but it's plus 2x. Equals what? Negative 22. I'll take that. So to solve for x, you're going to divide by what? By 2. X will be what? Negative 11. Now, if x is negative 11, you got to solve for y. Pick any equation. I'll pick the second one. Again, no reason, because I picked the first one, the last example. I'll just change it. So let me take the second equation. I could have picked the first one. And replace x with negative 11. Five times a negative 11, which is what? Negative 55 plus 2y equals negative 8. To cancel the negative 55, we're going to add 55. Two y equals 55 minus 8, which is, what's 55 take away 8? 47? So what is y equal to? 47 over 2. Or 23 and a half as a decimal number. So the solution, you always write x first, y second, alphabetical. Your solution is negative 11 and 47 over 2. Or negative 11, if you want a decimal value, 23.5. If you reverse them, that'll be definitely wrong. Definitely. If you put this one first and that second, that's wrong. X is always first, y is always second. So sometimes when you add them, you don't eliminate one of the variables. You got to massage it a little bit there, play with it. Let me try another one. This is actually a very popular method of solving a system of linear equations. Again, just by looking at it, if I just add them, do I eliminate any of the variables? When you add these, do these cancel? No. When you add these, do these cancel?
Yes, but only one.
What do you mean, one cancel?
Because it's negative y plus 5y, wouldn't it be 4y?
Yep, but then disappear, right?
No.
Yep, so we didn't eliminate. You're right. When you add them, 3x and x is what? 4x. There's a 1, you're right, that's a minus 1. Minus 1 plus 5, that's plus 4y. Our goal is to lose one of the variables. Did we lose one of them? No. So that means I got to do extra work. Now you got to decide which one of these variables you want to eliminate. You can eliminate y or you can eliminate x. If you decided to eliminate y, I just can give you a hint there. You want that number to be what? If you want to eliminate y. What is it? 5. Exactly, because that'll be negative 5y. So when you add them, that's gone. So to make it negative 5y, I can multiply the entire equation by 5. If you have your heart set up on eliminating x, not y, then you want that number to be what? Positive or negative? Negative, so you'll have to multiply this by what? By negative 3. So you have two options. You can either multiply this by 5 or multiply this by negative 3. Either way, you will eliminate one of the variables. So any preference, which one?
The top.
The top by what, 5? Okay. That means leave the bottom alone. You multiply the top by 5. 5 times 3, 15x. There's the minus. 5 times 1 is 5y. 5 times a negative 2, which is what? Is that negative 10? Mm-hmm. Leave the bottom alone. And now let's add them. What is negative 5y plus 5y? Gone. 15x plus x? 16x equals what? 0, good. And to solve for x, what do you do? Very good, divide by 16. X equals 0 over 16, that's a 0. Now we grab either equation, top, bottom, doesn't matter, and replace x with 0. 3 times 0, that's 0. 0 take away y is negative y equals negative 2. What is y equal to?
-2.
Try again.
+2.
Positive 2. Because that's a negative, negative 1. And negative 2 over negative 1 is positive 2. So my answer, x is 0, y is 2. 0, comma 2. Let's give you a challenging one a little bit there. Any question on this one? Four x plus 3y equals negative 19. 3x minus 2y equals negative 10. Again, if I just add them straight without doing anything to them, it's not going to work. 7x plus 1y or y equals negative 29. Not good. I need to lose one of them. Since I see a plus and a minus, probably my mind going to be thinking about eliminating y. But here's the problem. How am I going to make this number 3 or that number 2? Because they have to be the same number to be able to cancel them. without using fractions. I'm not a big fan of fractions. How can I make these numbers the same?
Could you multiply both?
Okay, multiply both. I like that answer. By what?
You can do 1 by 2 with
I'm going to cross the coefficient. Exactly. I'm going to take that number and put it down here, and take that number and put it here. So instead of trying to make one of them fraction or multiply by a fraction, let's multiply both equations. Multiply this with that number, multiply the bottom with the top number. So this will give me 2 times 4, 8x, plus what? 6y, negative 38. The bottom number I'm multiplying by 3, bottom equation. 3 times 3x, 9x, 3 times 2, 6y, 3 times a negative 10, negative 30. And now look at that. Perfect. No fractions, nothing. Gone. 9 and 8, 17x equals negative 68.
What, positive?
We're positive.
Oh, no.
We're adding them, yep. X will be what? Negative 68 over 17, which happens to be negative 4. Again, once you know one of them, you grab either equation, and replace x with negative 4. 4 times a negative 4 plus the 3y equals negative 19. Negative 16 plus 3y equals negative 19. Add 16 to both sides. Three y equals negative 3, which means y equals negative 1. So the solution is negative 4 comma negative 1. When I'm using this method, when I'm solving by elimination method, I like to have x and y on one side, the numbers on the opposite side. That's what I like to have. That doesn't mean that's I'm going to have all the time. The book is not going to be that nice to me, or the test, if I'm taking a test, it's not going to be always that nice to me. So every once in a while, they'll change that on you. So let me try one. A little bit different here. Three x equals 4 plus y. And this one, 9x minus 3y equals 12. Now again, I don't like the way this one is looking. I like x and y on one side, the number on the opposite side. So let me do that first. Let me take the y to this side. I'm going to have what? 3x minus what? Y equals to 4. Now, if this was a test question for me, I will tell you right now, I'll probably use a substitution method. It's already solving for x almost. But I can use this method too. And this one will be what? 9x minus 3y equals 12. So all I did so far, just move things around to match the look I like to see. Notice if I add them, that's 12x. If I add them, that's negative 4y. Nothing is eliminated. Okay. What do you want to eliminate? X or Y? Y, okay. That means you need that to be, instead of minus Y, you want it to be what?
Plus 3y.
Plus 3y, very good. If you want to make it plus 3y, you got to multiply this equation by what?
Negative 3.
Negative 3. That's a multiplication here. What's negative 3 times 3x? Negative 9x. What's negative 3 times a negative y?
Plus 3y.
Plus 3y. What's a negative 3 times 4? Is that negative 12? And the bottom one, leave it alone. And let's add them. Gone, gone, gone. 0 equals 0. What does that mean? That's a true statement. That's always true. So when you have a true statement, what does that mean? You actually have the same line. If you were to graph them, remember the first method solved by graphingly? If we were to graph them, the two lines will be on top of each other. So you have an infinite solution. When we say infinite solution, we try to write one of the equation down. Just to let people know, anything that fits this one will also fit that one, because infinite means not any point out there. It has to be on the line. If I change this problem just to here, if I made that number 12 instead of, I made it 10 instead of 12 here, what will happen when this is 10?
0 equals negative 2.
You get 0 equals negative 2. Is that true?
No.
So if you have a false statement, what does that mean?
The lines are perpendicular.
Parallel, you mean? No solution. Why there is no solution? The two lines are parallel. So it depends. Again, if you have 0 equals negative 5 or negative 2, we know that's false. That does not equal to negative 2. There is no solution to a problem like this. It says the two lines are parallel. So without graphing it, even with this method, I can tell you if you were to graph them, if their answer is going to be intersect at one point, same line, or parallel. Let's give you one to try.